Hi, this is Kimber Brown. I am coming to you from my bedroom floor with my phone hairband to a lamp to get you this video. This is for one of the major assignments for Mr. Leach, and I'm going to go ahead and derive the sine half angle ID using a version of the cosine double angle ID. So first things first, I've got to choose which double angle cosine ID I can use to derive sine theta over 2 equals plus or minus 1 minus cosine theta over 2. So, of course, I have two double angle IDs that I could use. The first one being cosine 2 theta equals cosine squared theta minus sine squared theta, right? So this one's easy because I have a sine, right? I have a sine. I could derive it from this one, but there's an easier one to use, and that's the second one that we are given. That is cosine 2 theta equals 1 minus 2 sine squared theta, right? That gets rid of the cosine. I don't need to worry about two cosines, and I only have one cosine, which is the same one I have right over here. So first thing I'm going to do, I'm going to use different colors in homage to Mr. Leach because he really likes his colors. I'm going to use one of these colors. I'm going to say theta equals x over 2, okay? And we're going to replace these with x over 2. And that will help me first get the idea that we are taking a angle over 2 for everything. And that will help make things a little easier for me. So cosine 2 times x over 2 equals 1 minus 2 sine squared x over 2. Okay, awesome. So what's the first thing I can do here? Well, I can already see I can simplify things a little bit more by not canceling these out, but multiplying out the top and bottom to reduce them to 0. So we're going to go ahead and do that, and we're going to go ahead and do cosine of x equals 1 minus 2 sine squared x over 2. All right, so we have that all set. So what's the next step? I want to get sine by itself because I have sine theta over squared, and I want to get that by itself. So what I'm going to do is I'm going to go ahead and subtract each one by 1, and then I'm going to have a cosine of x minus 1 equals negative 2 sine squared x over 2. So I can already see I don't have a negative over here. So I can go ahead and multiply this by a negative. So I'm going to go ahead and take a different color because I have to stay colorful. And we're going to multiply each side by a negative. And this is also where I'm going to go ahead and switch these two just to make things a little easier because I know I want sine on this side. So now I know I have 2 sine squared x over 2 equals, so I can multiply this out, I can switch these up to make it a little easier. So 1 plus cosine x. What does this look like? Oh, that's not a plus. I'm sorry, that should be a minus. Okay, awesome. So that looks like 1 minus cosine x. I already have that up there, right? So perfect. I'm on my way to getting the right answer. Bring in a third color here because, you know, I gotta be extra. I can divide everything by 2 to get even more by itself. That'll be sine squared x over 2 equals 1 minus cosine x over 2. What does that look like? That looks like up there, except we have a square root here, and we need the square root over here. So we can just go ahead and take the square root of both sides, and then that will take away the square root on this side, and give me the square root on this side, which is what I need. So whenever we square root one side and we put it on another, we want to make sure we add the plus or minus, because that can be a positive or negative for every square root. So I'm going to move this up here. We're going to go up here. I'm going to say this is this, and then we're going to have sine x over 2. Awesome. Perfect. That's exactly what we want on that side. We're going to equal that to plus or minus. Whenever we take the square root from one side, we got to have the plus or minus on that one side, of course. 1 minus cosine x over 2. And I have derived this order right here. So you can see my steps. We can go over my steps one more time. I first replaced the theta with x over 2, so that I can show that this is a half angle identity, because we are taking the half of an angle, right? Okay, so, and then I go ahead and simplify this side to get to x by itself. So cosine x equals 1 minus 2 sine squared x over 2. Awesome. So now we do even more steps to get sine by itself, subtract by 1, then multiply each side by a -1, just so I can get this negative out of the way. And I messed up right there. So if I'm multiplying this out, I need to make sure that I am writing, so it's negative cosine x plus 1, because of that, because negative times negative is a positive. So it's 1 minus cosine x, just to be a little more cohesive. Then I can divide this by 2, and I get that over 2 on that section right there. So it's 1 minus cosine x over 2, and that's all set. The only thing I'm missing is the squared. The only thing that I have extra here is the squared. So I go ahead and take that squared. Oop, you can't quite see that. Take that squared, and that will help me to get rid of those on that one side. And now I have a plus or minus on this side. So sine x over 2 equals plus or minus square root of 1 minus cosine x over 2. Thank you so much, and this is Kimber Brown signing off. Thank you so much, guys.